How are you doing? Hello, Ram. How are you doing?
Hey, I'm good.
Good. Can you hear me okay?
Yeah, I can hear you. I still joined from I'm still on the way. I just joined from mobile. I'm trying
Okay,
to
okay. No worries, no worries. I understand.
find out
Yeah,
the.
yeah. Yeah, if you're driving, you can, hang up. No worry. No need to drive and, participate. Just go to your location and then dial in. That's okay.
All right.
Yeah. Hey, Mukesh, how are you doing? Hey, David.
Hello, good. How are you?
How are you doing? Yeah, how are you guys doing?
Doing well, doing well.
And thank you, David. Thank you for that nice comment that you had on LinkedIn. That's awesome.
No, yeah, well deserved. Just trying to get the word out.
Oh, wow. I think that was really nice that you wrote that on your own. That was just beautiful. And I'm not sure if everybody has seen it, but I should pull it up because I think it is awesome. It is brilliant. So let me pull it up, see if I can find it quickly. Yeah, there it is. Yeah, looks like Peggy Peggy also saw it, and Peggy clicked like button on that one. So this is something that David wrote on his own without anybody telling him, and that was just beautiful. Thank you, David. Thank you.
No, you're very welcome.
Thank you. So what David wrote, I'm just going to paste a link for it to have copy link to share. That link, copy, paste it in Slack so you have it. And I have taken the liberty of taking that link and making it available on the site here for other people to read, especially in this section. So I just want you to know that I've done it right there.
Oh, very cool. Thanks.
Yeah, I took your picture and posted your comment right there at the link. So thank you again. Thank you. So let's see who else is now online. Maybe we can just quick look. We have David, Dennis, Mukesh, Ram, and I think 3 of us are not here yet, but I guess we'll have to start. They will come whenever they find time to join online. They'll come and connect. And we are recording, so there's not a big issue there. So let's recap on what we were doing the last time and proceed ahead. If you remember from the last time when we were doing this, we were doing the exercise with a tool to help us produce reproducible environments. So reproducible application deployment environments where people can just do some things that they would like to accomplish. Let me just change to the keyboard. Instead of this mouse, I will switch over to that pen and paper, which is much better than this thing. This mouse doesn't help me. Unless, if I want to write, I think it is better to use this tool instead. So that is my combination mouse and pen. That you probably have seen this before, but I'm just showing it to you because you can see it. So I'm switching over to that and then opening up this thing called OneNote and also adjusting my pen properties so that they don't get confused with mapping the monitor number 1 like that. That should not confuse my pen at all. So it should go all the way. Now, having done this part, what I would like to do is to just recap what did we do the last time. What we're really trying to accomplish is, have some cloud somewhere, and that cloud should deliver a service to our customers. And the service includes everything that the service endpoint will do, including, the machines here, the configuration, and the application, and all of that. Application, dependencies, configuration, the machines themselves, all of that, whatever it takes to build a complete service. That is what we are really after, to put everything in perspective, put everything in one place, and then play it on some raw cloud. I'm calling it raw because it is not prepared. It is raw for our customers. We cannot just give them raw machines. It doesn't make sense. So we have to prepare our service in our company, inside ideally a Git repository, where we will put all these things. The application sits here, the dependencies, the references, the configuration, the machine interconnectivity, VPN designs, whatever else we have, put that in a Git repository, and then press the play button. Or maybe the play button gets pressed automatically every so many minutes, 30 minutes, 1 hour, every 10 minutes. It's your call. This press play doesn't have to be manually done. You can play it automatically, or maybe play it continuously, plays all the time. And so the idea would be that you make changes, modifications, and then you do a Git commit and a Git push. As soon as the Git goes to a commonly agreed upon location, let's say the GitHub location, or let be Bitbucket location, whatever that location is, Bitbucket. So basically these are services for Git deployments. So you can push your Git repositories to these locations. And as soon as you have a commonly agreed upon place, the play button will play by itself and your service goes live. That's the overall idea. The overall idea is to take your services live from your Git repository all the way to the customer so that they can receive and consume the services that you want to really deliver to them. And now we are going deeper in the aspect of, this play button, like what does actually play? That takes a Git repository and then plays it onto some cloud that makes a service that your customers can consume. And then, of course, when they consume, they will give you money. That's the whole idea. You give them value and you get money from them. And that's great. That's business. So you are playing some tool. And this tool that we are focusing right now is the Chef tool. Chef tool, as you remember, comes in two different, it can be played in two different ways. The solo way, or I should say the Chef solo way, and the Chef client, Chef server. Okay, there are two modes of operation. We are focusing this one the last time we did. We do a little bit more here before we switch over to this one. And we'll go deeper in this also. So I'm giving you a perspective on where we are headed with what we are doing. Essentially, we'll have something here that we want to create value for the customer and get paid. And we are doing this through some tooling. For example, right now, the Chef tooling, and this is the focus, Chef solo. That's the focus right now. Here are some exercises that we did. At the last time we did this one, like running Chef in solo mode. So we had that thing here in a folder. We called it using Chef solo. That one. And so this folder has some content that we used, and then we ran this sh run Chef solo, and provided our password and all that good stuff. And it did a lot of things for us. Like, for example, I don't know if it is Nginx or, yeah, we modified it for Nginx. So that should be running by now. We should see that Nginx is running and all that good stuff. But what I want to be able to do is make some room for the next exercise. So we want to delete this Nginx business. So this thing should go away. It should die. And so this Chef client is actually, when it runs on its own, it will continuously keep bringing that Nginx back up and running and keep it alive. I don't want it like that. I want a clean slate again, like back to zero. So I will come out of this folder and remove it. So there are some sudo permissions needed. So I had to use sudo instead. So sudo rm-rf using chef solo, go away please. So it's gone. Nice. Now that Nginx is still running there, right? So I need to kill that one also. So there's this process ID that I need to go look. That thing is running. I need to kill all these guys. So I'll kill them, sudo kill -9, and then 2193, 2194, 2195, and 2196. All these guys go bye-bye. And now I don't have any, I still have them. But did I not kill the right one? Or 2192 is not dead. Okay, that's the reason why. So let's go kill them. 2192 also. 2192 is the root process that I forgot to kill because I did not pay attention to this number. So it did not kill anything actually. So we have to kill all of these guys again with these new numbers. They got regenerated worker processes. This is the main master process. The master process did not get killed, and other guys got killed, but that was pointless. So we're going to go and kill everybody else also, like 3187, 3188, 3189, 3190. Kill everybody. And now we have still some worker processes. There are more spawned. Okay, let's kill them all. 3188, 3189. Did I not type it? Did I type 2? Oh, that's the reason. I'm not typing properly. Okay, I'm getting lazy now. So kill. Sudo kill -9, 3188, 3189, 3190. And kill. Please go away. Yeah, you're not there. And I would like to uninstall that Nginx package that I don't need anymore. So I'll go sudo apt-get remove Nginx. Please go away. And along with that, all the dependencies should also go away, which is auto remove. Force them out. And so all of that will disappear and we'll have nothing about Nginx. It's basically a clean slate. So now we open localhost like this. And you will see that Firefox is not able to see anything because it's unable to refresh that. Refresh, it's a cache page. It should be unable to connect. That's the exact point we would like the machine to be in so that we can proceed to the next exercise. So we have this Firefox checked. It's all clean, no Nginx there, no residue, no running process. And that's the point we would like to begin. So we have done this exercise, like running Chef in solo mode, and some modifications of using Nginx in place of Apache and all that good stuff. So we go next unit. And here we will have, this is the Nginx modification. So further, next unit. Here in this segment, it is a little bit elaborate, I should say. It's quite detailed in its variety of how the goal of this particular segment is to get us a solid understanding of what Chef nomenclature is and how each of these components fit together to accomplish the level of complexity that we need to actually handle when we are dealing with professional deployed services. So these services that we would like to deploy in some cloud, that requires a lot more nuance, a lot more detail around specifics about how to do certain things. And to accomplish that, these tools actually provide you with a whole bunch of capabilities that we would like to understand. So I don't want to throw these things at you by the taxonomy is quite heavy, and it's all related to cooking, like chef and knife and cookbooks and recipes and all that. So it may sound funny, but they have a meaning, specific meaning associated with each and every item. So instead of throwing all these ideas at you at one shot, which is like a textbook way of doing, I would rather give examples, like a simple thing about what this thing is and how do we put pieces together, and at the end you will find all these things fit together. So that gives you a good perspective on each of the components, the ingredients, along with along with some taxonomy as to what this thing is. And then we go further in making complex usage scenarios. So we'll put that into practice. But this particular segment, which is this, what I would like to say, this is what unit module number 6, which is this one, using Chef in solo mode. That one is more of an exploratory in nature. So it gives us an understanding of what these things are that constitute the tool generally known as Chef in its incarnation, in its variations. So we'll see that. We'll learn by example, as opposed to like looking at the Chef documentation. You can have Chef documentation, and all of that is very well documented right here, by the way. And so you can read this on your own. And I'll just paste a link for you, so you can also refer to it on your own if you feel like, whenever you have time. But that's just the official documentation, and you can totally read that. There are some videos also that you should be able to read, and lots of things to read here. This is the index page, by the way. This is the site map. So you have lots of things to study and understand, but that's the hard way of doing it. I would rather give you simple examples that you can easily relate to. And that's why I would not focus too much on the documentation itself, but instead this sequence, which is custom created just for an easy understanding of what this thing is. So let's begin. Let's begin a simple idea at a time and understand what do we do, how do we put these things together. So I'll keep talking about this thing called the Git repository, right? Whatever I put in the Git repository. So in the context of Chef tool, we call this the repository. We call it a kitchen. That's the name. So you put everything related to cooking in the kitchen. That's the idea. So whatever you put, the kitchen is the place. It's basically a folder. You can call it a directory, but that's what it is, basically a folder. And you put that directory or folder in a Git commit so that you regulate it very nicely, exactly know what is going on in there and all the changes. You can manage it very carefully. And that thing is called the kitchen. Some people also call it the Chef repo. That's the name you will occasionally find when you're reading, talking to other people. They will use the word, put that in your Chef repo or put that in your kitchen. So those are the two names generally collectively used for the folder itself. Now the folder creation is as simple as, just create a folder. So we'll do that. Here we go. Create a folder. That's it. Go in that folder. Now we are in that folder right there. And in that folder, we have nothing. As simple as that. Like, that doesn't contain much. That absolutely contains nothing right now. So inside that folder, we want to put a file, and the file I'll be calling by this name. And the name is too small to read on a distance, but I'll adjust that later on. The font size apparently is way too small for some reason. Well, I know for a stupid reason, I should say. I should have fixed that, but it is too small for reading from a distance. I'll make it big. It is called gem file. That's the file that I would like to create right in this folder, which currently has nothing. And so the idea behind this gem file is basically a gem file. So if you know Ruby somewhat, and you know that I have been talking about these things called gems, which are basically Ruby packages. And so a gem file is a collection of gems that we need. So we would like to grab some gems from the Ruby Gems website, rubygems.org website, and we'd like to grab those gems. We can go there and download it, but it becomes boring when you have like 400 gems you need or 300, some large number of gems. It becomes boring for you to go download one by one. So that's why we have this systematic structure to put together to grab all the gems we need from a gem file. And that's what this file is going to be created right in that folder here. So the easiest way to create that, I think, is just use atom space dot. This dot is for this current location. So open the atom editor in this new mycloud folder. Open it right in that folder. So we'll do that. Atom will open up and it will be showing you that particular folder, which is the My Cloud folder. In that folder, you press Control N to create a new file and Control S to save it. And we'd like to save this empty file in the My Cloud folder, and the name should be capital GEMFILE, gem file. So that contains, all the gems I need. Write down here. So gem number 1, gem number 2, like that. You can keep writing like that. You can write all the names of the gems. That's basically what gem file is. Not in this fashion though. There's a systematic method of writing a gem file. And that method is like this. You get these gems, these specific gems for me from that location. So this location happens to be this location. You go to Ruby gems and get me these versions of these gems. That's the idea. And you will use a tooling to get these gems down to your computer. And the tooling is called bundle. So you basically bundle these gems up. It will go to that site and bring these gems and make it ready for you to use. That's what we are going to do, is basically run a bundle command that will look at the gem file itself. We are going to save this file. It's a save, yes. Now our gem file contains this listing, which is given here. And at this moment, what we need to do is just run bundle, or to be specific, run bundle install. So right now in our folder, we have that file called gem file, which looks like this. And what we need to do is run bundle install. Or just bundle is also okay. You don't need to type install, just bundle is okay. Just same thing, basically that's the same thing. It is going to go to that site called Ruby gems and bring down the gems we need. Gems we need are these guys. We need that particular thing for us to be able to play with in this exercise that's coming up. And so it's an easy way of grabbing all the gems we need. And we grab them, install them, and they're ready now. They're available to us. Now, having done this part, I must say that some companies prefer that they don't go to this public location, Ruby gems, which is basically controlled by public. And what we are doing here is this another discipline approach, a very well-disciplined approach of noting down specific version numbers that I want, not random things that might come up. So if I remove them, if I remove these numbers and go like this, then I will get whatever the latest number is for Chef for Night Solo. But I may not want that, because what happens is on the internet, with people contributing, collaborating in the open source, randomization might happen. And so it is in your interest to keep tight control of what you're dealing with. Otherwise, things will change on you, like left and right, change on you on the fly as you're doing things. Things will change because things are so much in flux that you have to regulate your own discipline. And that is the reason why we do everything in the context of a disciplined approach of managing, maintaining, running, whatever we want to do, just put everything in tight control. Otherwise, you will have no idea what happened. If you don't, specify the version number like this, like where was that? Undo, Control Z, yeah. Don't specify like that version number, you will get randomized. If not right now, at some point. And you will cause conflicts, and things may not work the way you want, and that is a problem. And the way to avoid that problem is to be disciplined about versioning with version numbers of gems that you're using. So even though you will see that the version of gem, or rather, the version of Chef that we have right now installed, the last time is 12, 14, 89. I'm saying I want to have this version, 12, 10, 24. That's the version I want. The version I have it installed the other time, the 2 days ago version, was this version. But I may not want that. I want this one. And you can regulate it that way. So now, I'm just telling you that I want to get that version, and I installed bundle, and I have put a gem file, gem file in there. But still, why do I not get the version I wanted? I wanted 12, 10, 24. This version of Chef is what I wanted. Why did I get 12, 14, 89? That's a good question that you will have. And if you don't have that question, please ask that question because it's a valid question. The question is, or question should be, why did I not get 12, 10, 24? Instead, I get 12, 14, 89. I thought you were going to give us some discipline, a systematic method of locking it down in form of a gem file. Whatever happened to that? So the reason we did not get that version, but got the latest version is because you're actually ignoring the gem file when you're running this completely. You're ignoring it. In order for you to force the use of the gem file and the discipline that gem file provides, you need to run this in the context of the bundle that you just ran, like this bundle install that you did. You have to run it in the context of the bundle, in the context of the gem file. So you have to provide that context very, very explicitly. Something like bundle execute. Execute everything with a prefix of bundle execute. And then say chef client and show me the version number. It will give you exactly what the gem file says. And it will run that particular binary, not your random latest binary that you may not want. You don't know. I haven't actually tested this particular version. I tested this version, so I have it in my gem file. So my project requires that particular version, so better use that one. And you can bring the discipline by enforcing it like this in the context of the gem file. That's this bundle exec command. So remember, this is the thing that you need to run every single time. Make sure that your Ruby commands are running in the context of bundle exec. Otherwise, you will get randomized. You will get something different than what you thought you were getting, which is not what you want. And things will keep updating, like this one is a new version. This one is a tested version. I'm not saying this one will not work. I'm saying that I want this version, so I got it. How did I get? Gem file. That's the concept of this dependency management. And by the way, these things, the Knight Solo, Bark Shelf, Chef, and Rack, and all these things are basically dependencies for your application. So you're basically managing these things in a very tight discipline and forcing that execution through bundle exec. Having said, some companies, as I said, do not want even their, especially, very large companies that are very, very particular in terms of what software is coming into the company. And therefore, they may not like this idea of going to a public site, rubygems.org, and grabbing gems from there. So you could, in practice, modify this to something like, boeing.com, for example. You could put Boeing specific Ruby gems, or just say gems, and have this internal site where you can put all the gems that you would like to have your company to be using. So make a distribution like this internal to your company within your firewall and force it. Everybody will use this location to grab the gems from, and everybody will centrally manage what gems go there, so that everybody in the company are managing through a very carefully vetted, systematically controlled approach towards getting open source software. This is how you could regulate. I know, specifically Boeing is very particular in terms of how the software comes into the company, and there is a systematic process in terms of how you manage external third-party applications, and you have to go through a software approval process. So you can regulate that like this by letting the source come from a specific location, like this internal location. This command will run and work only inside the company. It will not execute outside. It will fail. Say cannot find gems.boeing.com. It doesn't exist outside. It may be I'm just making it up, but you could tightly control even within your company, and while still using open source. That's the idea. So you can modify the source, and then this gem file will go to the internal site, grab the gems. You need to run a gem server, by the way. And that internal gem server reference is to be given internally to your gem file, and everybody in the company, all the people who are using it, needs to know that that's the location. Like everybody right now knows that gems publicly are available at this location, rubygems.org. That's where gems come from. That we know, all of us know. And that's where these things are coming from. So we have used that. But for a private scenario, you could regulate. Keep going forward. The idea behind bundler, I think you understand that, which is to be able to grab these gems, put that in the context of execution in the scope of a gem file, so that the execution are disciplined and they're honoring the version you specify. They're not running random versions that may exist.
So is bundle exec tied to a specific directory or?
Yes, directory.
Okay.
Like the My Cloud directory, it will look for the gem file inside and force it.
Okay.
So almost everything in Unix is tied to a local folder. So in the order of precedence goes with the local folder. Then at the higher levels, until it goes to the root, sometimes other applications will have other specific locations called out. But the order of precedence begin with right here, this folder. And so it runs only within the context of the folder. Everything else is maintained outside. Even though your gems may be located somewhere else, they'll pick up that particular version and run it for your execution. So that's bundling. And we'll have more such examples in a variety of different types for cookbooks and for other things coming up pretty soon. So that was a frame of reference. How do you grab components you need, put them together in a disciplined fashion? That was the first part. Now, let us use another tool called knife, which is, of course, related to cooking. So this knife solo is actually a tool that will use the chef solo command. So we have that knife solo installed right now in our folder here. And so what we need to be able to do is to be able to understand what does that. Let me make it a little smaller. And so the idea is for us to build and prepare the foundation, the kitchen, the folder we will work on. And so we created a folder, put a gem file, bundled it, and now we are able to run whatever we want in the context of the bundle. Now, having said this part, we are going to use another tool that we just downloaded through the gem file syntax right here, the knife tool. And this knife tool will help us do a couple of things, such as initialize a kitchen, prepare, cook, and bootstrap, and clean. So the 5 operations here are defined. And these ideas are basically init, the knife solo init command is used to create a directory structure. So in here, in our folder, we just have 2 files, gem file and gemfile.lock. The lock is basically a cross-dependency matrix that stipulates every single version and its cross-dependency in form of a structure. So this is automatically generated file, and it is created by the bundler software, which is also a gem, by the way. And it has all the dependencies called out in a systematic fashion in that lock file, which you should also put that in your Git commit. So this is where it says, how did I get all these gems, what versions, and all of these are defined in the log file. You can actually delete the log file comfortably, and you still have the gem file. All you need to do is just run bundle update. And it will create that log file one more time by looking at all the existing gems that you are going to use, and that log file gets ready. And you can see that it comes back online, comes back available as in when you run the bundle update again. Now, the idea behind initialization of a kitchen. So we want to run this command, knife solo init. If you do that, it will convert this particular folder into a kitchen with all the components, all the ingredients needed to manage and run chef appropriately. Now, our scenario of usage in the previous example that we ran chef solo on a machine that we wanted to execute. So this is where we ran. This is the Cloud Genius workstation. We ran this chef solo right here. But this model is like a simple and starter point. Let's call it a starter point. In a scenario where you will actually make use of, you will have this workstation that you have, You will run chef solo here. But in the context of this tool called knife. And what this tool does is basically makes this thing run remotely on the cloud. So when you're running knife something, you are executing chef here on some machine M1, machine M2, like that. It will execute this thing here and here. It's a remote execution tool. So it's a knife, basically, it's a tool. So when you run knife, you're sitting right on your workstation, but you're remotely executing chef in these machines. They will operate knife. So knife will help you run chef solo on the remote machines. That's the idea. In our previous example that we did, we ran it directly locally, which is not very interesting actually. You know, we are not doing anything with the cloud. So we want to make this thing run on the cloud. We want to actually run this solo tool using the help from knife tool to run this chef solo here. Chef solo needs to run on the boxes wherever we want to run something. So that should be remotely executing, and you can do that. We have this tool, we just installed it here. It's called knife solo. So that's the tool that we will use, and it has several operations. Like for example, this operation called init, and then we have 4 more, like cook and prepare and cook and bootstrap and clean. So in init, then there's a prepare command, there is a cook command, there is a bootstrap command, and a clean command. So that's pretty much it to start with. So 5 commands. And this initialization is a one-time thing. You initialize it right here. So it creates a bunch of files basically. When you initialize, it creates a bunch of files so that knife will operate properly. When you say prepare, knife init, knife prepare, knife cook, knife bootstrap, knife clean. When you're running knife init, it is creating a files right here. When you say knife prepare, it is going to prepare this machine or that machine. When you say cook, it applies the DNA onto these machines. That's the way to think. So let's recap. Initialize. So the word knife init. This thing will prepare a bunch of files on your local machine. So it will look like this. Bunch of files, folders, like that. That's the initialization command. Then on the same machine, you're going to run knife prepare. And when you're running it knife prepare, it actually prepares those remote computers, M1, M2, like that. Any number of machines you might have in the cloud, they will be prepared with chef. Then you run knife cook. M1, knife cook M2, like that. It will actually execute chef on the remote machine, basically inject the DNA and make it become whatever you want to become. It will become and take shape of the design that you want. So that's the ultimate outcome, that you actually cook these machines so that they become what you want to create. You prepare to install chef. You cook to run chef. That's the usage. Now, what is bootstrap? There was another command called bootstrap and clean. So the bootstrap command, which is basically knife bootstrap, is a combination command equals prepare followed by cook. So it's a shortcut command. It does preparation, which is basically install chef, and then cook, which is basically run chef. So 2-step, 1-shot bootstrap. And clean basically wipes it, removes it, brings it back, reset if you want, roll back, things like that. So that's what we are defined here. So knife solo init, solo prepare, solo cook, solo bootstrap, and solo clean. Removes the kitchen from the target. That's the idea. So let us actually grab our initialize our kitchen in the next step. So we want to do that. So in the next unit, what I would like to do is actually initialize a kitchen, which is what we are going to do. So in that folder we have, which is called the My Cloud folder, right? This one, we are going to initialize a kitchen. So it is basically knife solo initialize dot. This period is important. You want to tell the initialization method to initialize a kitchen right here, like dot. So we'll do exactly that. We'll say initialize the kitchen right here and watch Atom in the upper segment. You will see a bunch of things getting created right in that folder. As I run this command to initialize a kitchen, I'm basically creating a kitchen. So here it goes. And it will create a bunch of things. It said, I'm creating a kitchen, I'm creating a knife RB in the kitchen, I'm creating cupboards, that's a joke, and setting up bookshelf. Bookshelf is a play on the word bookshelf, by the way. And bookshelf is where you will put your cookbooks. So it is basically to manage cookbooks. Is this thing called bookshelf. And the guy who created it is actually pretty smart. He said, I would like to not name it bookshelf, because even though I would like to call it bookshelf, I would like to not name it like this for a simple reason, is it competes with Google searches. So, if you have a very distinctly different name, such as bookshelf, it will automatically give you top level ranking in Google searches or Bing searches. And that's the reason why they chose the name bookshelf as opposed to bookshelf. But that's the only reason. The meaning is bookshelf. And so you can go to that bookshelf site and you can read more about it. It is also an open source project on GitHub. And that is what we will be using. And this is basically a place to manage cookbooks. And so this is conceptually similar to bundle command, where in the bundle command, you have this site called Ruby Gems site. And you have a file called gem file, where you list out gem names, gem number 1, gem number 2, like that. And so you run bundle. And when you run bundle command, it will look at the gem file and do what? Go to the Ruby Gems website and download these things and set it up for you. So very, very similar, very, very similar is this bookshelf. Is this bookshelf command, except it looks at a Burks file, in which you define cookbook number 1, cookbook number 2, number 3, number 4, and it goes to the supermarket website. The chef supermarket website that you saw the last time, right? So when you run bookshelf, like bundle, it will look at the Burks file and grab these cookbooks for you. And it will grab from the supermarket and place that in the kitchen at appropriate location. That's the idea. That's the purpose of this bookshelf that we have installed. And we are going to use it now. To use that thing, but before let's finish up the init discussion. So here, the knife solo init discussion that we have. We have created something here. This is the kitchen foundation. So we have created a bunch of things which look like this now. It's a elaborate folder structure with a folder for almost every single thing you want to keep here. So basically everything is sitting inside that folder. And here are the contents. Let me tell you, almost every file here is empty. It's basically empty. It's a placeholder. So we have this file, git keep, empty. This folder, empty. Git keep, empty. All these things are basically empty. They're basically references for you to fill it up with things that you want. Same thing here, git keep cookbook. The file that is not really empty is this one. And we like to modify this actually a little bit. So we'll do that. But that's how you initialize a kitchen. Once you have the kitchen ready, it looks like sort of like this, like you saw in the Atom view. And the idea behind the .chef folder is a hidden folder. Dot is a hidden folder. And a hidden folder is where you keep your secrets. So like .ssh folder in the other example, you might remember this one. This is where you keep your password, your secret private keys and all that. So that dot folder is hidden, this .ssh. Similarly, this .chef is also a hidden folder. It is not visible without explicitly calling out. If you just say ls-l, it doesn't show up. You say ls-al, it does. This one, it was missing in the other view. It is not visible to you, visible to ordinary users, cannot see it. It is hidden. Now, having said, Atom does show you, because Atom is a professional editor for developers, so they can understand that it is going to be made visible. So it shows you that folder, and that is where you keep your secret stuff. So this knife RB is a place to keep your different configurations that are secret. So we'll talk more about this later. But that's that .chef folder. Basically, it is a place to keep your private key, your credentials for other cloud companies like Amazon Cloud, DigitalOcean Cloud, Azure Cloud. You will grab your credentials, put that in that particular file called knife RB. That's where your credentials will go. So AWS access key, AWS secret key, DigitalOcean token, like that. You will put these things here. And so you will save them, but then you have to keep them safe. And that's why this is hidden, and you want to keep it absolutely in your control, never lose it. And that's the .chef folder. Almost everything else is fairly intuitive. So the cookbooks folder is place for you to store cookbooks. The data bags folder is a place to store data bags. And we'll talk more about data bags at some point. Environments are something that you define. This is a production environment. This is a staging environment. That's a testing environment. So you basically randomly come up with the names that you like to choose, and you call them your environments. So this becomes my production. If you have some other tongue other than English language, you can use your native tongue and also use environments for your own language if you like. Nothing is prevented, except there is one environment called the default environment, and that is not modifiable. But every other environment, you can just make stuff up. You can call it whatever you like. So these are basically conceptually segregating your cloud environments into production, staging, development, whatever else, pre-production, post-production, God knows what. That's how your nomenclature will differ. And you create these environments and you associate them you put them in that folder called environment folder. We'll do some specific examples to associate that. And you basically are classifying your cloud infrastructure according to what you call a particular collection. Call it production, call it testing, call it staging, call it whatever you like. That's what you do in the environments folder. You define those things in there. Now comes the idea of node. And node is basically a machine in the cloud. So basically, whatever you have here, for example, the example I keep, let me draw it again. So you have the workstation here, and in that you have your kitchen, and then you have these other folders like I'm describing right now. And this is where you will run your knife command, and this knife command will basically remote execute chef. And this chef, wherever it runs, is called machine number 1, machine number 2. In chef language, this is called a node. Nodes are where chef actually runs. You can remotely execute them, remote execution, using the knife tool. But on the nodes is where chef runs. These nodes eventually become your servers in the cloud. Chef calls them nodes. Just don't make anybody confused about the word node. Node is basically the server, the boxes, the machine, the instances, the droplets, whatever else you can call them. But these are machines that are in the cloud that chef calls nodes. And this folder, nodes folder, will contain a reference to every machine that you will manage through this folder. So anything you will manage through this folder, it will have entries corresponding to the nodes you will manage. And we'll create them automatically. You will see them happening. Then comes the idea of a role. This role folder will store role definitions for whatever you want the machines to become. Like you want a machine to become a database server. So it becomes, it takes on a role called the database role, so that it becomes a database server when it grows up. And so you will have to create a role called database role, and you apply that role to this machine, the node M2, and then the DB role gets applied here, for example. And if that happens, then this server becomes a database server automatically, just because you applied the DB role. But to define the role itself, what it means, whether it is a Postgres database or a MySQL database or Microsoft SQL database or Oracle database or some other database, Mongo database, you have to define those things in that DB role that you will put in your kitchen in the roles folder, and then apply that role to this M2, and then it becomes your database server. That's the idea behind the roles folder. And then comes this folder called site cookbooks, which is conceptually very similar to this folder called the cookbooks folder, except there are two folders for the same kind of purpose, both storing cookbooks, this one also and that one. Both of them store cookbooks. But I think it makes sense to segregate the cookbooks you create from the cookbooks that other people create. These cookbooks that you create are specific to the site. They are site-specific cookbooks created by you and placed right here. These are the cookbooks that come from the supermarket. They are open source, created by people who are probably experts in the domain that you're talking about. And that's the cookbook location where you will grab from the supermarket, you keep them here. And ideally, you don't change them. Doesn't mean that you never modify them, you just don't touch them. Do not. You will do an override here. Override this one if you like, but whatever you change, you keep them separate. That is your creation, your creation. So keep them separate in this folder, site cookbooks, and you override whatever you want that other people will create, so that you are not messing around. It doesn't cause any conflict. Things will change. You might want to change something, but this is not, you don't control what people are giving you. You can override them with your creations on top of what they are doing, but just keep them segregated.
So it's like a customized cookbook for your
Yes.
preferences.
Yes, this is your custom. So custom cookbooks that you create, put them here. And whatever you're getting from the outside, yeah, keep them here. That makes it a very clear distinction. So that's the reason why we have these two different folders, one here, another here. They both are empty right now. And then there is this git ignore folder, which you probably know. You want to ignore everything that is in the cookbooks folder for a simple reason. This entire folder, you are ignoring it, is because you don't want to put all of these things in your Git repository. Not at all. Because you don't want to carry that burden of copying and reproducing it in every single location, because your team members do not need to get whatever they can get on their own. They can also go to the supermarket and grab the cookbooks. Why do you have to give them through a Git repository? No need to. There is no need. And that is the reason why, instead of giving them the entire collection of all the cookbooks that you want to use inside a Git repository, it is better to give them a list. Call it the shopping list. Go to the supermarket, take my shopping list, and just pick and choose whatever you want according to the list that we have specified for the project. And this shopping list is conceptually like the gem file, and specifically it's called the bugs file. And that is something that you want to actually provide to your Git repository, so other team members on your team can just also go shopping in the supermarket and grab the books you need that are specified in the bugs file. And this file, yes, you put that in a Git repository and all that, but not the books themselves. That's why we have this ignore in the Git ignore file right here. Then we have the bugs file, which is where we will list out, oh, get me this book, get me that book, like that. You will specify names of books, version numbers, just like we said, give me that gem, give me this gem. You will do that in this folder, in this bugs file, which is like a shopping list. You also have this gem file, which is your shopping list for gems. Bugs file will be a shopping list for your cookbooks. And so that's the thing that this file will contain. You can specify that you want to go grab the books from this location, bookshelf.com if you like, or you can specify a custom location, or just go to the supermarket. You basically control where the book's coming from. So similar to what we had in the other discussion here, you control where the gems are coming from by this link, the Ruby Gems website. Here you can control where the books are coming from. It could be an internal API or books.microsoft.com. You could control it internally if you like, something like this, and keep all the cookbooks or internal to the company, and don't have to share it with anybody, and you regulate it very carefully. So you can then, internal developers can say, get me this book, get me that book, and that works. So that's the idea of the actual kitchen elements. So let's go deeper in next step, which is we actually have to get some book, like get me this book, get me that book. And I want to get that book from the supermarket, not this location. So I don't have access to that cookbooks.microsoft.com location. So let's go remove that. Instead, I want to get that cookbook from the supermarket. And I want to get that particular version number. So here we go. Get me the Nginx cookbook 276. By the way, this is the cookbook version, not the Nginx version. So if you go look at Nginx site, you will have versions of Nginx as 1.11.4. That's the machine version for Nginx, mainline version for Nginx, 1.11.4. So this version is the Nginx product version. This version is the cookbook version. So just don't get confused with the Nginx product version and the cookbook version. They're two different things. You can see that in very clearly when you go to the supermarket. The version on the supermarket is 276. That actually configures the version of product that you may want, but this is the cookbook version. This is not the product version. We don't want the product, we just want the cookbook. So that's what we are getting. We want to get this particular Nginx cookbook from the supermarket. Like the last time we downloaded it by clicking a button on the supermarket. This time we want to go grab it using a tool and force the discipline of getting that exact version we want, 276. And we can very simply do that just like we did with the bundle command. In the gem file context, we'll do this with a bugs command. Bugs. Bundle exec, bugs install. So it will install and get us those books like this. Bundle exec, bugs install. It will look at the bugs file, go to the supermarket, grab all the books you need and bring them down. And not only that, it will grab all the other dependent books that may be necessary for your infrastructure to be complete. For example, we just wanted one book, and this guy went ahead and brought down these 17, 30, maybe how many, 11 books. So lots of books here that came down. All we wanted was this. All these others are dependent books that are also available now with us. So we have them. They're stored in a safe place. Do you know what that safe place is? It is not here, and it is not here either. So where did it go? It is not in the cookbooks folder yet. I thought you were going to put that in the cookbooks folder. Where did it go? And so Workshelf doesn't actually put them right here right away. Instead, it keeps it in a safe place and will put them in the cookbooks folder only when you use them. So it doesn't actually clutter your folder for no reason. The actual location happens to be, just so you know, .workshelf. That's where the books are stored, right here. You can see them in this location. It is a hidden location called .workshelf. In your home folder, under cookbooks, you'll have all these books. So they're sitting there. We need to go back, go to My Cloud folder, and be there. So we need to be working in that folder called My Cloud, just so you know. So we are there. So we installed these books. They're available to us. We can grab them. So we can systematically control what books we can get by the burks file. And similar to the gemfile.lock, we have a burksfile.lock, again, calling out dependencies among a variety of books that we need. We just needed only one, which in turn needs several others. So that lock file describes that dependency map completely, just like that. So with these things in place, in hand, we succeeded with the burks install. We should also, so some of the write-ups here, these steps are not required, by the way, but I'm describing them here because you can use it that way. So it's more of an explanation of what these tools can do for you, not necessarily an exercise step sequence. So the following step is not required. You can run it, but not necessary. If you do that, burks vendor, it will actually drop the books in a folder in your location right here. Not this folder, but a separate folder. It will vendor the books. It will basically provide those in your folder. Vendoring means providing in your folder. It will copy them over there from that secret location onto your folder in a folder called burks cookbooks. You will see that happening when you run burks vendor. Or rather, I should say, bundle exec burks vendor. So it should be bundle exec burks vendor. When you run this command, Workshelf will vendor the books in a new folder called burks cookbooks, and it will place it inside your folder right there. And so here it is. We now have a folder called burks cookbooks, newly created, which you can see it has all the books. And we don't need them right here, so we can get rid of them. And so that's the way you can vendor the books if you like, bring them locally if you need to, but I cleaned it up. We don't need them. It is sitting in there, and that's a good place to keep them safe. We don't need to clutter our work area with unnecessary things. We don't need them right now. So proceed next. Next, what we have is to define a machine to work with. So when I say machine to work with, in our workstation, we are here, and we have this kitchen here, which is basically a collection of folders and files like that. And so we are working in here, and we want to now actually operate on the cloud. And this is where we will get a node in chef terminology, which is basically a machine. Let's call it M1. So that's the machine I want. And I want to define a node that I would like to use and apply this tooling on that machine. So that application or the play that I would like, not application, I should call it the play of the chef tool. I want to play chef on that node, for which I need to have a node. Then I would like to define that node will have a name and a purpose in life. Like, what will you become when you grow up? So I will have to get a just enough machine from somewhere, an embryo, and then inject a DNA in there. So I will do exactly what I just said, which is get an embryo, which is, to me, an embryo looks like this. And I'm getting an embryo right now from this location called DigitalOcean, which is where I will grab a blank new machine, empty slate, just a raw droplet. That's what I want to get. So this machine will give me a raw machine, like create a droplet, click, like that. Plain and simple, we know that already. And so what I want to be able to do is, before I do this, I would like to make sure that I have my private key provided to them. Sometimes I accidentally delete, sometimes I deliberately delete my keys. So I want to make sure that I get my key ready in hand before I create a machine. I'm going to create a machine, which is what this machine is what I'm going to create right now. And then play Chef on that machine. Sitting right here, I'm here happy and running Chef remotely on that machine through remote execution. The tool that I'll be using is Knife, the tool that we have. And we are building a kitchen for it. In our kitchen, there is a folder called Nodes. And in that folder, I need to create something, a reference to this machine. That's what I'm really after. So I am going to create this box, call it a good name, good sounding name, and put that name right here. And also associate DNS, just to make it easy. This box may not get a DNS name to begin with, so I have to go make a DNS name. To be specific, what I'm really doing is I'm going to create a node and put that in the nodes folder and call it, let's see what the name I have chosen. I think I have chosen this name. So web1.cloudgenie.us. So the name I would like to choose for the machine is web1.cloudgenie.us. And that's the machine name that I would like to assign to this box that I'm getting from DigitalOcean. And this box will give me an IP address. I will assign this name to it. But just by me choosing this name for this box does not make it work with DNS. So I need to go create a DNS record, an A record for this name with this IP address. And then this DNS resolution will actually work. Me going here and saying, I would like to get a DigitalOcean Ubuntu machine for $5 droplet and choose it in the San Francisco #1 data center and get a new key here from my machine right there. So I'm grabbing my public key, by the way. And this is my public key. I would like to grab that. See how I copy, I skip out on that portion. We don't need that. Sometimes it is okay to keep that, but some clouds do not like it. Some clouds want it. This one doesn't want. But actually, this one doesn't care. But I'm just calling out that the key is actually from that point all the way to this point. And this is a name comment reference. So this is a comment reference. The key ends right here. So I'm going to grab that, put that in here, and call it my ID RSA key and add it. That key I will be using. I just selected that. And I'm going to choose Ubuntu, $5 droplet, San Francisco #1, add the key. One droplet is good enough, and the machine name should be web1.cloudgenie.us. Now, me choosing this host name has absolutely no connection with the DNS naming, like zero connection. Just because I chose that name does not mean that the name association will automatically work. No, it will not. You still have to go to the DNS server and create an A record. An A record is an address record for this name to map to this IP address. So we are going to choose this name and create the machine, wait for it to give us an IP address, and then take that IP address to our DNS server. In my example, my DNS is in this location. So I will log in, and then I'll go to DNS and look for my Web1 machine, which apparently points to this machine I had several, I don't know how many days ago, but sometimes I was playing with the same exercise. So that Web1 machine has an IP address which is wrong. Then I need to get a new IP address from DigitalOcean, and there it is. So I copy it, give it to the DNS. Now I have it correctly pointed. This means that my web1 points to this box, this node to be specific. That node now automatically correctly resolves because I gave a DNS entry like this. Your DNS entry will be different according to your DNS provider. But remember, that's what I just did, set a DNS record. This basically means you can run a dig command, like dig web1 and say, give me the A record, please. And it should give us this IP address, this one. If the DNS has propagated worldwide, this machine IP address should pop up as a result of an A record query. That A query is what I'm running right now. And we should get that IP address, which is the box IP address we have from here. This one, same one, 104.236 matches. So now if you visit that site, web1.cloudgenie.us, you will see nothing because there is nothing running. I mean, it is empty. The machine doesn't have any web server running, so it is unable to connect. There is no Nginx there, by the way. So that's why even though your IP address is mapped to the DNS name, you still don't have anything there running to show you anything on the browser. That's why you don't see it. And so having understood that part, we are now continuing along in this defining and working with a node section. So we have to define a node. The node definition happens in a node file. Node file looks like, it goes in this folder called nodes. And we need to name that file very, very precisely. The name has to be this. It has to be nodes folder web1.cloudgenie.us.json. That has to be the name of the file for the node to correctly pick up and operate on the right box. And that has to be this precise name. If you don't want to use DNS, that is okay. You can use the precise IP address if you like. And that is also IP address.json. You can also take that if you don't want to use DNS, that is also workable. You don't have to have this DNS thing going. You can still work around by using IP address and calling out specific name like described in the write-up. So I have it written down, but I need to create that file in that nodes folder with that name. So I will be saving this file, empty file right now in the nodes folder. So this nodes folder will have a file name called web1.json. That's the name, web1 cloudgenius.json. So I'm saving it. Right now it is empty. I will fill it up. Fill it up with what? With the DNA that I would like this box to become when it grows up. It has not grown up yet. It is still a box that is just enough operating system. It is an embryo. I want to make this box grow up into something for which I'm going to put the DNA fingerprint right here in this location. So here is how I define a DNA that I would like to put in that node file. Basically, it looks like this. Save. So it has a run list definition that is empty. So basically, it will do nothing. And it is a valid, complete node definition. All it does is nothing. So we have to add things in there as we want to grow the function, grow the purpose of that box. We can add it. But right now, it is empty. We can add it as simple as saying, you know what? I want you to become an Nginx server. So take this as your recipe. So we'll take that recipe, Nginx, include that in the node definition, which is the DNA fingerprint. I will say, you know what? You go become an Nginx server and save. So when I save, this node definition is now changed. I still need to run chef through the use of knife tool for this to actually take shape. And right now, this will, when I run knife on that remote machine, it will make it a Nginx server. And you can see that this thing pops up here at that time, not the web1. Right now this is empty, but we will see it growing up to become an Nginx server through the knife usage, the usage of knife tool as simply as that. So next, what we want to be able to do is make sure that we are able to connect to that box directly already. So are we able to connect to this box? Let us test. So we will do a quick test like this, SSH, root at IP address. Did it connect? Looks like it does. So it connected. Nice. We come out of it. Next, SSH, root at web1.cloudgenie.us. Does it allow to connect with the name? Yes, it does. And we connected successfully. Nice. We come out of it. So it seems to connect. In this example, I think I have written some steps to start a machine that you can skip because you already know it. You already know you have a coupon there, $10 credit that you can use, and then proceed. So get a machine, get it functional, get it connected like this. And now we are going to run and prepare that node like this. So it's a slightly involved command. I'm going to type it out in a notepad and show it to you very clearly what is here. So in this command, I'm going to basically say, I should describe this in a different fashion, maybe a little bit bigger. So the idea here is we are going to run it in the context of bundle execution, which you understand. Let's go to that machine is better. So here, let's open up a notepad and paste it. And what I'm going to do is adjust the size a little bit. And here you can see that I'm running in the context of bundle execution. I'm running knife solo. And I'm going to prepare what? Prepare this. What is this? The IP address, the box. If you don't have DNS in place, you can just use the IP address right here. If you like, you can basically substitute the IP address from the machine that you have and put it right there in place of that word like this. And by the way, these slashes are multi-line commands. So basically it's a one long command with slashes in between to make it easy to read. So you don't need to have those slashes, you can get rid of them, but then we have to put everything in one line like this, which is also okay, but it's hard to read a very long lines. That's why I have those slashes in place. And you can get rid of those slashes like this if you like to remove slashes. So we are basically preparing that node using knife in solo mode and in the context of bundle execution of the gem file that you know already here. That gem file discipline with those specific versions, that's what we want to run. And we want to prepare that box, this IP address. And since we are getting lazy, we don't want to use DNS, this is the approach you will need to take. And you have to call out the -n option to make sure that the name is called out clearly, because your name reference is by that file name you have here, which is web1.cloudgenie.us.json. So that name has to match with the command that you're running, and then it will work just fine. However, in my example, what I have is actually use DNS, like you should. And so in that case, you can go a whole lot simpler. You can just say, cut all this and just prepare the box. So prepare that web1.cloudgenie.us box for me. So you know this, the command prepare is to actually install Chef. And so that's what this will do. Once the Chef is installed, our next step would be to cook it. And when you cook the box, you basically are giving it a purpose in life. You're injecting the DNA. The DNA injection we are giving is this one, which says you grow and become an Nginx server. And so that's this cook will do. If you want to simplify these things even further, you can forget the prepare and cook step and just say bootstrap. Bootstrap. It will do all of these things in one shot. Prepare followed by cook. And get your machine ready with Chef, install Chef, and then run Chef. All of these in one step. Line number 14. If you are going to be not using DNS, this line needs to be replaced like this. I think you should just use DNS. Yeah. You should just use your DNS and your custom domain name you might have from some provider like GoDaddy, for example. But if you don't have those, then here is the workaround. When you don't have DNS server, or you feel lazy about doing it, that's when you do.
So we have to be in that directory, right? And then you have to have either web1.cloudgenius.us or maybe another file name that I use is m1.json. That would be okay.
In case of this cloudgenie.us, like for example, you will not have access to the Cloud Genius servers. You have to replace this with something like dennis.com.
Well, I mean, that has to match under the nodes.
Oh, yes. Oh, yes. Yes.
Okay. So if I do something simple called M1, that will work, right?
Yeah.
M1. Okay.
Yep, it will. And you have to basically match it in the nodes file also. So anything you have in the nodes folder, that also has to match.
Sure. All right.
Okay. So if you're doing it the right way with the DNS, when you use DNS server, then you do it like this, line number 12, 13, or alternatively just one shot 16. Similarly here, or one shot 9, like that. So that's the steps that you will follow along. If you are doing it the way I am doing, I will just run the very last line here, which is line number 18. And by the way, I cannot use dennis.com, so I need to replace that back all over the place. So I need to just replace all of them with my domain, so I can have that working. And so that's what you will be doing if you are going to use DNS, which I recommend that you please do. In that case, let's run this step, prepare step. So that's the step that I would like to run. I'm going to take that preparation step, prepare the box, and make it like so. Like here is the step defined here in the example that I have, where I'm preparing the node for use with Chef, basically installing Chef. In here, let's go execute that.
So does the bootstrap, it adds the spices and then it cooks it all at once?
Yes, correct. Yes, exactly. Good way to say that. Spices, yes. Nice way. Yeah, exactly. Yeah, it does a combination step, so you can see these things together. So bootstrap it's a combination step, prepare and cook together. And I'm just pasting the whole thing right now in Slack chat, so you have it handy. You will need to modify that accordingly, but here is a snippet for you, so you can readily get copy and paste if you like. You have to still modify a couple of things. So having said that part, let's go to executing a couple of things here, which is the idea I have is to first prepare. So I'm taking that line number 12, preparing it. So copy, go to the terminal and hit it. So when I hit this command, it will actually attempt to remote execute Chef on the target box. So you're going to basically see that I'm sitting on my workstation. This is the workstation. I'm going to run knife solo prepare. It will know where to go, what to do. It will just remotely connect to the box that I have here, which is web1.cloudgenie.us, that box, and install Chef on that box sitting right here. That's what you will see when I'm going to execute that command right here. And off we go. It is going to remote connection and install Chef remotely and still do no DNA injection. So there is going to be just installation of Chef, and you will see that this thing still doesn't work because it's not going to actually run Chef. It's going to install Chef specifically. It's downloading Chef and installing. You can also see a couple of interesting things right here. For example, your Chef version is getting installed is 10, 12, 10, 24, which is exactly what you wanted, not some random latest Chef version. So you can basically regulate what gets installed in the cloud. It is installing this specific version of Chef. It told you that it installed setup Chef, and thank you for installing Chef. That's what it did. And it got the packages loaded up, and we are ready now, which means we should be able to go to that machine directly. And in there, say Chef client, what version you got? It will tell us that it has the version of client that we installed, 12, 10, 24, which is what we wanted. So coming out of that machine, we don't want to go muck around with the machine directly, as you know already. You're not touching the machine directly, but I'm just showing these to you. Showing these things to you so you can see and understand. Next step is to actually cook. So the cooking step is very similar, except instead of prepare, it is cook. And so off we go. But before we cook, let's go check the website. Does it work? No, it doesn't. It's not supposed to work. Now when we run the cook command, it is going to remotely connect to the same machine. This time we'll actually run Chef and actually upload our kitchen. The whole kitchen goes there and runs it right here. And when you do this, you will see a success message at the end that tells you that it did whatever you had the DNA fingerprint in your kitchen called out for that node. The node is this node. For whatever that purpose in life that you had defined for the node, that purpose in form of your DNA JSON file that you wrote.
So when you do the code, it's from our workstation, which is our VM over here, and then you do the SSH, or FTP transfer to the other side. Is that correct?
It is not FTP, but yes, conceptually you can think like that. Conceptually you can think it is FTP, but it is not. It is secure transfer. So FTP is not secure. It is going to do SFTP, secure,
Okay.
or some FTP or SSH or some other method.
Okay, so basically it's grabbing whatever we have on our local image and then shuffle up there. Is that correct?
Yes, you will see that happening, and I'll point out to you as it does. So as you watch, it'll happen just like I described. And let's go execute right now. So you will see that this recipe Nginx is going to kick in into effect, and you will see that the cookbook gets this folder gets populated right now. This cookbook folder will actually contain books as soon as I run it. So here we go, executing now. So it is going to run that Chef command on the remote machine. So it's going to check the Chef version. Then it is going to install bulk shelf cookbooks into the cookbooks folder. So now we have a bunch of cookbooks in here. Back in here, we are going to use all these books and rendering them, then uploading the kitchen over to the machine, generating solo configuration, and then doing a bunch of things. Basically, Chef is running right now remotely. And let's go back a little bit, read that missing portion that we missed. So generating solo configuration, uploading the kitchen, generating solo configuration, installing these cookbooks, running that Chef version 12, 10, 24, compiling these books. So you can see that compilation happens, and all these green indicators are basically showing you success. By the time the run should have finished by now. And so, yeah, it did finish. It did several actions in 20 seconds. And at this moment, you should see that Nginx is running, which means we should see a 404 page right here. Right here, when I refresh, you should see 404 not found, because this is actually Nginx telling you that there is nothing to be found. Before that, there was not even Nginx. There was nobody to tell you anything. So it was just unable to connect. Now you have the Nginx server, which tells you that there is nothing to be found. So that's what you have. I mean, that's what you get. So this is probably the only time that you should feel excited about a 404 page, I guess. The only time. Oh, I got a 404, nice. So that's the idea. So in here, if you go back to the machine and connect directly to it, you should see Nginx running there. And it is. There is a master process and a worker process. Those guys are running. And you can see that it is giving you 404 because there is no server defined to actually show you anything. But it is absolutely running Nginx like you can see here. So that's the concept of remote executing using what we just did. Prepare, followed by cook. So in this step, I'm describing the cook command here, how to cook and all that. And you get excited about 404. Let's go modify some things here. You can see idempotence. For example, you run that command again. I mean, you just come out of that machine first and run that bundle exec cook command one more time. Off we go. It will again upload the kitchen because it doesn't know what you may have changed. So there is no method for it to actually keep track of. And so it is going to send the kitchen one more time and then do nothing because there's nothing to do. And then it will come out saying, I did nothing. And that's great. So it is going to run the chef solo command remotely and will gladly do nothing at the end of it and tell you that it did nothing. And it took 6 seconds to do nothing. Your Nginx still runs, which is on the web one, not here, web one dot. So this thing still runs. You can go and mess with it. For example, you can say that I want to go and kill. I want to go destructive. So sudo kill -9 3265 and 3360. So go kill something. That's great. So since you killed the web server, this Nginx will disappear and you have unable to connect. Now you can come out of it and have bundle exec knife solo cook again. It will go and fix the problem. As you've seen in the very first chef exercise, you saw this behavior already. You saw that same behavior we are repeating, which is we are doing it remotely this time. The only difference is we are on the workstation. On this workstation, we are running it remotely on the target. The target we have named as web1.cloudgenie.us. And we are executing similar concepts through remote execution using the tool called knife. Prepare, knife cook, and those two are combined called bootstrap. And before we did this thing, we had to initialize our kitchen. So there was a knife solo in it. There was the initialization step. We constructed our kitchen folder. And that's where we are working with. In the kitchen, there is a solo step in between I'm forgetting. So let's not forget, it is knife solo prepare, knife solo cook, because it is using the solo mode of operation, not the server client mode of operation of Chef. That's what we have here. So it should now be back up and running. The site should be giving you a 404 one more time, and that's great. Let's define at least understand some of the concepts in terms of how roles can play. How roles can play a role in our kitchen. So you have this thing. Don't say it. Yeah, here you saw this node file. In that node file, we called out this particular recipe, and this was the run list, the purpose in life of the box. What I want to be able to do now is slightly modify this thing and create a new file called a role file. So this role file will go and sit in the roles folder. In this roles folder, I would like to create a new role, and I will call this role the web role. Like this, web.json. And it's an empty file, sits in the roles folder. We'll call it the web role. And in here, what I want to be able to do is define a purpose in life in a different fashion. It's just, there are many ways of doing the same thing, by the way. The simplest one we just did. We'll like to modify a little bit, doing it slightly different. And here, I just created a role for web role, what I would like to call it, a web role. So this is the role name. This is the file name which sits under web.json. The web role is in web.json. Description can be whatever you like. I mean, it's an English language descriptor. You can put whatever you like. It doesn't matter. This type is defining the type of the file. A JSON class is defined, and you can here define specific ports you want Nginx to listen, 80 and 443. The idea underneath here is this concept of a chef attribute. You saw this example in other examples. In the very first time we ran, we were able to look at attributes for Apache web server. And so here are default attributes for Nginx web server. And you can see that here are the examples that Nginx will like to use. For log directory, Nginx prefers to store the logs in var log Nginx folder. And that's an attribute. You can modify the log location to another location if you like. And you can do that through calling out specific attributes. Similarly, this attribute called listen ports is the port you want Nginx to listen for. So port number 80 for HTTP traffic. Port number 443 for HTTPS traffic. You can specify these listen ports. And you can override them. And maybe you want to listen on port number 81 instead. Or whatever you like. It's up to you, your control as to what you want. And that way you can modify and override whatever the Nginx cookbook decides to do. The Nginx defaults will actually specify a listen attribute already. So we should go and search for it. So this word called listen port, let's go keep search for this thing in the entire folder structure. Let's see what we find. In the cookbooks folder, let's see what we have in, hold on. Folder. Yeah, I think that this is not coming in a existing cookbook. What we are really doing is asking Nginx to open these two specific ports and have Nginx process listen for these ports. And then this segment from line number 6 all the way up to this portion is a way for us to define that Nginx, when you run, you please listen for these ports. And the run list definition, we have moved it to the role definition here in this example, which means we should now modify the web1 cloudgenie.us recipe reference to a role reference by the name web. It's a indirection, a level of indirection that I just introduced, where I'm saying that, you know what, node, you should take on the web role, and role is defined like this. The role definition actually also has a run list, which in turn invokes the Nginx default recipe, which is this cookbook, and the Nginx inside there here has a recipe called the default recipe. And so that's the recipe that we will invoke through a role this time, as opposed to invoking through a node. In the earlier time, we are invoking the node definition through a role reference. And in that role, we have defined a run list, which in turn invokes Nginx. By doing this in this fashion, The benefit of doing it this way is that it allows us to define a role for once and apply it simply to a bunch of different machines just by the name role web. You can say that, all these machines just take on the role of a web server. So if I'm constructing a farm with 1,000 machines, all of them running Nginx, I don't need to call out each and every one of them with specific details about their attributes and other details, but just say, you know what, all of you, just take on the web role and go do it. And it will automatically happen. And there are further automations we can put. Right now, for example, in our example that we just ran, we created this machine here by hand. You can start machines through automation like you have seen before in other examples. And we will be able to do these things. The idea is to be able to automate. So I'm basically showing you nuts and bolts of pieces to put things together to build complex things as we go along. So this definition that you saw is of a role reference in the node file, which refers to this role definition, which looks like this. And that's what we have in the example. We should be able to invoke this simply by running the same command again that we ran before, the cook command. And that should go something very, very similar, except it will invoke a role as opposed to directly running that node definition, which is different now. As you know, this node definition does not have a reference to a recipe in a cookbook, but a reference to the role here. So if you repeat that same command, it will upload the new kitchen and execute the same exact outcome, except we have some override attributes defined, which are the listen ports. They are defined. They were not defined before, but basically they're the same thing. So you will see the same exact outcome like before, except some modification we did, which included use of a role definition. It is uploading the kitchen and running that thing right now, as we can see. The concept can be extended very simply by saying that, you know what, I want to have more roles, such as, by the way, this finished. And it did nothing successfully. This nothing should be showing up as a not found 404 page again. Having seen this, you can extend the idea of multiple roles by creating more roles like this. For example, I'm going to create just an illustration role right now. I'm not going to execute because it's probably simple to understand. So here, Control N to get a new file, empty file, and save it. Save it in that location called the roles folder, in where we have this web.json file already. So like the web role, I would like to create a database role, for example. So I'll create a db.json file there and save. When I have this empty file, in which I will define an example role for a database server using the Postgres application. It looks like this. So this is just an illustration. So don't run it. It doesn't make too much sense in running this because we are not actually making use of it. But the concept is that you are calling out a role in here and also including a recipe for Postgres. We haven't actually included the Postgres recipe in the Burks file. There is no Postgres cookbook here, so it will not going to actually run. So just remember, this is not going to actually execute successfully because we don't have the Postgres cookbook reference in the Burks file, which means our cookbooks do not have a Postgres cookbook ready for us to use. So this will fail if you run it like this, but it is purely an illustration. The idea is that we are including mixing and matching roles inside other roles or recipes inside other roles, and then including a reference to all of these things in a node definition, like maybe this. Something like that. You can extend and expand and add multiple roles to the same box if you like in this example. Don't run this, it will fail. Similarly, you can extend attributes and modify, like in the example of here in GitHub. You can see that this Apache cookbook, by the way. You're looking at the Apache cookbook from Sander Van Zoost, this guy. And so in there, you see that line number 242 is a quick example where we have defined, where did it go? Line 242 here. Yeah, so here we are defining the specifics around, I think they changed the line numbers. So I should go look at some other place. Hold on. I think the line number got changed. But specifically, the idea is to look in this section. So here you can call out that I want my listen ports to be port number 80 and my timeout value to be 300. You can specify whatever specifically you want for your example. So in that port number 80 example, we can expand to make Apache listen for not only port number 80, but also for port number 83 or 443, for example. So this is how you can provide override attributes. By default, that particular book seems to be listening only for port number 80. So if you go look at listen ports in the actual cookbook, that's what it looks like. And in the example, I'm suggesting that you can expand like this to expand to include other ports, and then invoke the Apache cookbook in form of a run list that you define for your web role. So this becomes your web role that you will like to use. And also you can modify, keep alive timeout values, make it longer a little bit, 30 seconds. If you're in a testing or development scenario, you can extend for your testing and development environment, you can extend the timeout value, the keep alive timeout value to be a little bit larger so you can test properly. And if you want to add extra ports, add more, 8080 if you like. Basically, it lets you override whatever the default choices that the original creators have made. So here we should have a listen port. It is by default listening on GitHub. You can see that it listens only on port number 80 to begin with. And the keep alive timeout is only 5 seconds. We can modify these attributes by going override and saying, I want to have a keep alive of something like 30 for my development boxes, or have an extra port opened up, these two extra on top of what we have already 80. And that's how you can modify in terms of using attributes to make changes, make overrides on top of what is already created. That's the core idea, is to be able to override what other people have done already and extend, build on top of what they have done. We should take a short break before we go on to other aspects such as defining environments. What does that mean? Actually, most of it is quite simple to understand and comprehend. So basically, most of them are files like this. Like this is how my development environment will look like that. So we'll go through that very, very quickly. But let's take a short break and we'll resume in 5 minutes. That's like 6:47 right now. 6:47. So make it like 6:55. And let's continue at that time. Take a short break and we'll resume.
Thank you.
You're welcome. Hey guys.
Hey.
Okay, let's resume. So the let me recap. I'm such a short-term memory that I forget what I was doing. If I take a break. Okay, here. So environments. So the next idea I want to convert and discuss is the idea of defining environments. Environments are conceptually a way of segregating your cloud. So you have this cloud, you have a bunch of machines here. These machines are spread out wherever they are. And you want to carve out, these machines belong to my test environment. These machines are my dev environment. These are my production machines. So you can call out like this specifically and basically classify. And you can classify your machines as test or prod or dev. You can choose whatever name you like, except this name is taken. The underscore default, that name is taken. So you cannot choose that name, but other than that name, all other names are available. You can just choose whatever name you like to classify your environment and set them in production environment, development environment. And that's the idea here. By defining environments, what you're doing is basically calling out that this is going to be my development environment definition. What does that translate to? It translates to a file that will look something like this and will become a part of your environment folder like this. And we'll call it dev.json. And so that dev.json file, you save it, it goes inside the environments folder. And this is how it looks like. You're basically defining that my environment will be called dev. That's the key part. You need to remember that the name here has to match with the file name here. The description can be whatever you like. The environment is the type of this file. The JSON class attribute is chef : /environment. These are predefined. And then the interesting parts are where you get to override the attributes. For example, here we are saying for development environment, extend my timeout values to 120, as opposed to whatever is defined by default. You could extend and modify. All the machines in the development environment will have a different timeout value. You want to keep the timeout values small in production and keep them large for you to debug properly in the development environments. You can modify this thing, and you can, by definition, have any machine that you put that in the development environment will have the Nginx servers configure automatically with the extra timeout values added on them. If you put a box in the production environment, it will take a different setting, not this. So you basically are classifying behavior of these machines different from these machines just by calling them out as these belong to the test environment. So let's call them the red guys as opposed to the blue guys who are green, the green guys who are production. You're basically calling it out separately and assigning appropriate values to attribute selections inside your cookbooks that you might have somewhere here deeper. They may be all generic to begin with. You can make specific across your different environments. That's the idea behind defining environments. It's very, very simple to understand, and you can execute pretty much like this. But the idea is that you can classify and segregate. That's the core idea. Moving on, the next interesting thing is actually pretty interesting. You will actually enjoy this portion. Is something that I would like to do another hands-on. So I'm basically closing these guys out. So I'm not. Yeah, I should save this. This one I should save. So save close. And now we are talking about the thing called data bag and what does it do. And I think this is somewhat interesting. You just have to be careful in this as well as the very next one, which is encrypted data bag. And so you will enjoy, if you have inclination towards security or aspect related to encryption, if you like those concepts, you will actually enjoy these things. So be careful in reading and also following along if you are doing it with me. So the next idea is I would like to describe this concept of a data bag and then the concept of an encrypted data bag. And we'll do these two things one after the other. First, beginning with understanding what goes in this folder, data bag, what gets stored in that folder. That's what I would like to understand quickly. So the idea of a data bag is primarily to store secrets. Typically, you typically store some values that you may want to use at runtime, that you need at runtime. And so, for example, the password I would like to use for my database server. When I set up my database server at the runtime, I would like to specify my password somewhere. I will put that in a data bag and put that safely inside this folder. However, that value, if I keep it just like that, without encryption, anybody can read it. And I would like to actually keep this thing encrypted, for which there is a slightly different aspect, very similar to a data bag, called an encrypted data bag. This is not database, it's data bag. So that's a very related aspect that you will see. So we'll play with those scenarios just a minute. So in order for us to work with data bags in Chef Solo, which doesn't have this notion of data bags at all, only the Chef server has that capability to manage and maintain data bags. So this is open source. So what people have done is constructed an equivalent structure to use data bags with Chef Solo, even though Chef Solo by itself doesn't support that. But other people came along from the industry, from the community, and prepared a solution that actually makes data bag work even with Chef Solo. And that's what we need to do, is to make sure that we are including a new gem that does it for us. That gem is this gem here. So if you go look at our gem file, which is that file right here, and we'd like to make a modification to this file, we'll make it look like this instead. So basically, the first few lines are pretty much the same, except that we are adding this one line, line number 13. So we're going to add that one line all the way like this. That is a reference to a piece of code that enables data bags for Chef Solo, for Nice Solo. So that is a new gem I'm including in my gem file, which means I need to bundle, which means I need to go and bundle update. So I update my collection of gems, which will basically go and grab that extra gem that I have invoked, and that new gem comes down in form of, where is that? Let me scroll a little bit. Oh, okay, scroll please. Yeah, here it is. Knife Solo Data Bag gem came down because we wanted it to come down, so it came down. Now this gem provides us new capabilities in our Knife Solo execution, by the way, which means we have new capabilities right now with our tool. And that new capability is expressed in form of new commands that get showed up in the terminal that are otherwise not there without this gem. So you can find those things that are there by running bundle exec knife dash help, but then filtering for the word solo. And here you will find a list of all the commands that deal with data bag. And so here are those 4. Those 4 new commands came down, which enable us to create, edit, list, and show the bags, the data bags and the data bag items inside those bags. That's the idea. So in a bag, you will keep items. And you will keep bag inside a folder called bags. So what does that look like in practice? You will have items that sit in bag, and the bags will sit in a folder called bags. So in practice, you will have a folder called data bags, which we have already. And inside that folder, you will have bags. Bag for this, bag for that. And that's a bag folder. Bag for something like MySQL, for example. Bag for some other purpose. And inside that bag, you have an item. It's called a data bag item. So you will put items in the bag and put that bag in a folder called bags, plural. And that's what you're looking at here is create a bag with an item, edit a bag with an item, list all the bags, or list the items in the bag, and show the bag itself. Those 4 commands allow us to operate on our bags, data bags, to be specific. So here is a command I want to run to create a bag with an item called pass, which is going to store my password. So here, the command, I'm going to copy it from this location. And I think I clicked the wrong button. What did I click? Yeah, that's what I wanted to get. So I copy and then execute. This command is going to run knife solo data bag create, and the bag name and then the item name. Both are the one after the other. So this is the bag name and then this is the item name. Let's go invoke that. And when I invoke that, you will see new items show up. New folder. Hold on, I think something moved incorrectly. I need to go undo that. This should belong here. Yes. So this data bag folder that I have, it contains nothing right now. But now as soon as I create a new bag and an item, you will see that it now contains a new item. That item will actually be created in form of a file that opens up in an editor. The editor will not be this editor, but a different editor called gedit that will pop up as soon as I hit this command. And inside that editor, it will let you create and modify and edit whatever you want in the bag, in the items that you create, and save them. It may sound exotic, but it's basically plain text files. Let's go see it. So I'm going to invoke this command. It will open up an editor. And in there, it says, please set the editor environment variable, which I have not done apparently. So for that, I forgot that I need to set the editor environment variable to gedit, which I need to do. So that step I think I have not done, which means I need to, it's neither in the notes nor in my machine. So it is not done. So let me make a note for it myself. And I will go address that piece right now. Editor environment variable, and I'll tell you what exactly this means. This is a necessary step. We need to make sure that we are addressing that part. So the idea behind setting an editor environment variable is pretty similar to what you have in Windows, where you set environment variables. And in Linux, you set environment variables in a file that you have for your machine. That file is specifically called .bashrc. That's the file name. It sits in your home location. And that's what you want to edit. And you will edit simply by saying atom and then home and then bash rc. And in that file, you have to open atom editor. It will open up this long file that kind of looks scary. Look for the editor word in somewhere in between. You will probably not have it. And so it is not found, which is nice. So it'll go all the way down and define an editor variable. The editor variable is simply export editor equals gedit. That's one line I want to write at the end of that file and save it. What did I just do? I added a new item, a new line item at the bottom of this file. Which file? This one. I'll first of all describe what did I add, and then which file. The file was this. That file is what I added. This one line, export editor gedit. And this allows me to set this environment variable called editor environment variable inside my terminal. That's what I just did. By doing this, I'm able to satisfy this need of the environment variable, which was not defined to begin with. Now, since I have defined a new environment variable, I need to terminate my shell and open it again. You can do it just like this, or there are other ways of accomplishing the same thing. But now we have an environment variable defined. How do I prove that? I'll just say set pipe grep and editor, and you should see it. And it shows up editor equals gedit, which means I should be able to go to that folder first, the mycloud folder that we're working on, and then run the command that failed the first time. And here we are going to create a new bag and a new item inside an editor called gedit that opens up like this. And so here it comes. It has an item in there. This is the ID equals MySQL item. And here I want to say, I would like to choose my password to be something really secret, like super secret password. That's what I would like to choose. And then this is the password item that I'm saving inside. And then I quit. And I should see that the data bags folder contains a new bag called pass with an item called mysql.json. As simple as that. Now this was created through a different editor for a purpose. The purpose is that in a subsequent step, when we will use the chef server, we will have no method to edit that data bag item except do it through a command line like this, because there is no way to edit that remote chef server based data bag except through commands like this. That's the only way you can modify. The only way you can actually successfully do that is through editor environment variable like this, like I set here. That's the only way to edit on chef server. In this machine, we are on a local box. We can just go to that folder and create a folder called pass. And in that folder, create this file called mysql.json. And that works out okay. However, this method will not be visible or accessible to you when you're dealing with a chef server. The only way you will have is this command line. And you will have to have a remote editor set. And we will get to that point in a subsequent exercise. But right now, I'm showing you this example because this is what we'll be using in a subsequent step also. So why not use it right now? So basically, we created this folder, pass folder, and put this item with a password. It is human readable. And that is something that I don't like. I don't want this to be human readable at all. I want this to be encrypted. So we will now, first of all, see that this created a bag item called MySQL and put that in a bag called pass. And this is the item, MySQL. So we have the item right there. And the bag is this one. and the bags are stored all in this folder. So bags, bag, item. That's what we have created. Very similar to this command, which is the create command, we can edit very, very simply. Just repeat the same command, except we can edit. So just like create, like edit, and it will open up the same method and allow you to edit. So here, this is a lame password, not so secret. And you will see that it will automatically open that particular file. Lame password shows up there, but that's local and it's visible, so you can see it, but not in the case of Chef server. There's no way to see it. The only way will be through this command like this. Now that was the edit command. Now you should be able to see the command, because since operating in a Chef server scenario, you don't have a way to actually access it visually. So you should be able to show that. Simply remove the word edit and put the word show to show the password right there. So show the bag, the ID is MySQL, the password is lame password. And you can also practically you can see this file locally, because it's local, you can see that. But this is not encrypted, which is what the reason I don't like to store password like this, for which we have a different method called an encrypted data bag. Very similar to what you're looking at, except it is not human readable. And to encrypt something, we need a key. So one more key. And we'd use this key to encrypt our data bag item. And that key has to be generated. And we generate right now, right here, locally, and put that in our secret folder, .chef. That's where it belongs. That's where it needs to go. And we'll put it right there just now. First, we'll create it. So in order to create a key pair, we need to run an open SSL library and generate 512 characters, random characters, like this. I'll use OpenSSL library to generate random characters, base 64, 512 of them, one after the other. Oop, here it comes. You will see that this is purely random. Every time I run it, you'll see a new random set comes up. And it's actually random, based on the OpenSSL library randomization engine. So here, this entire collection is 512 character long, except you see that it has line breaks in here. And I don't want line breaks, so I have to remove them. I can basically trim them out, remove them, simply by piping it through the trim command and removing all the carriage returns and all the new lines. If I remove the carriage return and new line, it will show me all of these together bundled up by removing all the new lines that we have here. So they will go away. See the comparison between this and this. There is a new line here which I don't want. So I want to remove them by filtering them out. And I just did that. And once I filter it out, I want to store the output of this in a file in that folder, .chef folder. That's where I need to go. I need to have a file keeping that encryption secret. So this entire line will actually generate a secret for me, and I will place that secret in that .chef folder. That's my idea, is to be able to generate a random 512 long character sequence and trim all the carriage returns and new line characters, and then forward that output to a file in the .chef folder, and the file name would be encrypted data bag secret. So this is the key that I will use to encrypt, and that key is I'm generating right now. Here it goes. The key got generated and stored in this location. It's a one long character sequence, 512 long. So that's the secret I have generated, and I will never ever share that one with anybody. The .chef folder keeps it safe. Now that we have the encryption key in hand, we want to make use of it to generate a different data bag, not this one, but a new one. Not this, but a new one I'll create right in that folder, and we will construct that command out like this. So in here, what I'm going to do is basically execute that. And before I execute, I'll elaborate what am I doing. And that is, what I'm doing is in the context of bundle exec, running knife solo data bag create. So knife solo data space bag. It is not one word, it's two words. That can be one word, by the way, but the syntax they have chosen is two words. So solo data bag create a new bag to store passwords, not the pass bag, but a passwords bag. And the item that I want to put in there is MySQL. And by the way, use a secret file, which is the encryption key that I want to use, this secret encryption key. That's the secret file I would like you to use as you create a new data bag called passwords with an item to store MySQL password. So when I execute this, you will see very similar approach. The editor will pop up, and there I'll see ID equals MySQL. I'll provide it with my super duper secret password, something like a password is very, very complex. So I'll say 1, 2, 3. That's a good one. Colon there. Okay. So here is my very, very secret password that I have chosen. It is 1, 2, 3. I should quote it. Yeah. Yes. Now I save it. Now, once I save this password, I should make sure that this 1, 2, 3 is not visible to anybody. That's what I want to accomplish. And I will close this file and close this editor and go see that there is this data bags folder, which contains a passwords bag with an item in there, very similar to this item, except this is in a different bag. And the bag contains this JSON file. But where is my 1, 2, 3? My 1, 2, 3 is not readable. It is there. It is encrypted. This is the 1, 2, 3. And the only way to get that 1, 2, 3 out of here is to use that secret, this one. There is no other way, practically, humanly impossible to get that secret out because we are keeping it encrypted. And this is exactly how you want to store your secrets when you are putting your passwords in a chef server, which is away from you. So you want to encrypt them and keep them like this. You will take this encryption and then provide it to a remote machine where it will actually run that database software. And that piece where you will decrypt and bring out that 1, 2, 3 out of this. We can do that simply by running the same command, this time without the word create, but the word edit. And we'll edit our own bag. And since we are providing a secret file, the encryption key, it will let us read that in human English. Like this, 1, 2, 3. We can make it 4, 5, 6 there and save and close. And you will see that the encryption has changed. This thing changed. And you can again examine, but instead of edit, I want to just see. So I'll say, don't edit, but show. show me my passwords, it will gladly show it to you, 456, because you're providing the secret file. Now, if you run the same command without the secret file, you will get the encrypted data. You will not be able to actually read the English, the human readable form.
So, quick question.
Yes.
The secret file can be kept anywhere that I prefer on the server.
You want to keep it on your workstation.
Yeah.
On your
But
workstation.
not specifically in the .chef folder.
Yeah, this is like the .ssh folder. You keep it locally.
Okay.
You want to keep it preserved, safe. You will
Okay.
provide a reference to the key as you run it, but you want to keep them secret.
So the reason why I was asking is anyone who installs Chef Knife, Knife Solo, and can they, if they have if they know where obviously it is stored in the .chef folder.
Yes.
So anyone can decrypt it and see the password.
Yeah, you don't want to give this folder to people. You want to give this only to your team members.
Right. Okay.
Only for team, this one. Only for those who need to know, they can get this. Other people, no.
Right, but my question is, so anyone who knows how Chef works, they know that the data bags are stored under the .chef folder.
No, data bags are stored in the data bags folder, not in the .chef folder.
Sorry, yeah, the secret key is stored in the .chef folder.
Yes, correct. Yeah,
So
that's true.
anyone who knows Chef can provide that path, what is stored in the .chef folder, they can get
But
that.
this folder is not going out to any machine out in the cloud.
No, that's true. So anyone who has the server, so access to the server can
Access
see
to
that.
your laptop.
Okay.
It has to be access to your workstation,
Okay.
not the server. This is your laptop. This thing is in your laptop, in your keys, your laptop, or your workstation. They're not in the cloud.
So I'm just trying to, I guess I'm just trying to understand in the
Okay.
scenario,
Yeah.
how does this key sharing happens?
Makes sense. So let me go explain this. So the idea about secrets is that there are a couple of things that you and your team members, so this is you and your team members, they're operating in a common shared Git repository. When you do a Git commit, you do not want to include this folder. In fact, you can be specific, and at least not at the folder level, but underneath the folder, you want to say, you know what, this goes in Git. This doesn't go in Git. You can go in very, very granular and specify what pieces out of even this folder goes in the Git repository and what doesn't. So that's a super particular thing that you need to be able to worry about. And you can control these behaviors in the .gitignore. In the gitignore file, which you will see here, this one,
Right.
you can specify.
Yeah, we can call out the files that we don't want to be included.
Exactly. Like that.
Right.
And no typing mistake. Encrypt, yeah. Encrypted. Like that.
And also bag.
Yeah, bags can go. I don't care. I want to check in the bags. I want to commit the bags.
Okay.
I don't care about the bag. Bags can be in the repository. No problem. I just want to. I want to keep the secret encryption key secret. I have no problem giving this to people. This one. No problem. Take it. What will they do? Nothing. They cannot figure it out.
Okay.
The only thing they can do is attempt to descramble, but that is not possible if you have this thing hidden.
Right. Okay.
Right?
Yes.
Okay, good. Okay, let's continue. So this part is actually an interesting part, at least from a security perspective. How do you encrypt, decrypt bags, and how do you show, not show, provided you have the encryption key. This key regulates whether you can actually decrypt this thing or not. This thing was not encrypted to begin with, so it's quite lame. It is lame. So I don't like this scenario. But this one is interesting. It is encrypted data. So you can give this out to people, I don't care. You can publish on GitHub, nothing happens. Nothing happens. Nobody can actually make sense of what your password is. And that's just how it is. The design is like that. So you cannot figure it out. That's it.
Is the data bags restricted to like only to a password repository, or does it go beyond that?
So data bags can keep whatever you want to keep. The example I am illustrating is using to keep MySQL password. You can store whatever you feel like in a data bag in a structured fashion that is representation of JSON, like this. Basically, this is an ID, a key value. That's the idea of a JSON. We have a key identifier, value, MySQL. Key password, value, lame password. So key value pair store is a JSON syntax. So anything in a key value structure that you can put in a JSON, you can encrypt like this. And still, by the way, that is also JSON. So you still have key value pair. So key is ID. This is MySQL value. Password is the ID. This syntax all the way up to here is the value, which in turn is also another key value pair structure. Encrypted data, and this IV, and this version 1 cipher AES 256 CBC. That's the algorithm, AES encryption algorithm. And as long as you have key value pairs to store, you can put them in a JSON data bag. If you put them in a JSON, you can throw it in a data bag, no problem.
So it's more of a global config repository, maybe?
Not global, but whatever you want to put for your context. So in tools like this, it is specific to a folder. So whatever you're dealing with the kitchen, it is specific to that kitchen, not global. There is no such thing as global. I mean, global, in fact, I would say is actually the folder. At the folder level, whatever you have is what your globe is. So that's how you define global.
Okay, so it's restricted. It's restricted to this data, this file structure. That's it.
Only in that folder. It is limited. Whatever we're doing is in that folder. That's it. And it applies to a given cloud design, and you're limited to only that. Nothing is global. So everything is all local. So basically limited to the folder, limited to what you're dealing with. So it doesn't impact other things you may be dealing with in other projects, other folders outside. Nothing gets impacted. It's strictly all within here. What happens is if you don't do it that way and you try global at the machine level, and then you have one folder, you have project number 1, project number 2 here, working here, and you will have something going global that conflicts. And you don't want things to go global. You want them to be remaining local to the project. So stick to the project folder, create all your mess in this location, and when you're done, you can put that in a nice Git repository and share it with your team members, and that's great. But if moment you put something outside the folder, that becomes global and gets applied to project number 1 here, this was 2, that causes a problem because then it is out of Git control. Your friends may not have it because it is global to your machine, and project 1 and project 2 will work fine, but this guy doesn't have this global thing. It only has the Git repository that you provided, so it will cause problem for him. You don't want things global. You want it to be specific to a project, all within the context of a folder that you tightly control through Git discipline. So there comes an exercise. And this exercise, what we are going to do is go to this location. So for example, I have this DigitalOcean there. I'm going to destroy this one and create a new one, like destroy, confirm. And the idea is that I have in the exercise, which I think we should do, is something like this. Set up a node, which is basically, yeah, take DigitalOcean, take any cloud, doesn't matter. Take some cloud, some box, get MySQL server, and ready with root password on that box with a command that you will run in knife solo, something. And when you do that, the outcome, the desired outcome should be something like the node is ready, accessible via SSH, only via SSH. There is no other web server here, just MySQL database server. It has MySQL server installed, running and ready with a root password that you select. The key is you select, meaning it should be in part of your data bag because you get to choose. And after you run Chef, this knife tool, knife prepare, knife bootstrap, whatever you choose, that you can log on to the MySQL prompt on that node with the root password that you select. And that's the desired outcome. So let's see how we can accomplish that outcome in the context of what we just discussed. So it's going to be a clean step-by-step exercise. Next, we'll see how it is done. A couple of things that I would like to point out here. The one thing that I would like to point out is that most of the time when you go to GitHub, almost always, things are so much in flux that it is mind-boggling. That's something that you probably know this already. But it is mind-boggling to see that things go update every day. And like this updated 5 hours ago. I mean, it is mind-boggling the speed at which things get developed. And so this is 12, 15, 16. What do we have running here? Without bundle exec, Chef client version is 12, 14, 89. So already they're on 12, 15, 16 and they bumped the version. So that means things will change. It changed 5 hours ago. It happens all the time. And this is a good thing. People are excited, contributing 17,000 commits and all that good stuff. But too much of a good thing can be difficult to digest. It can cause trouble when you're getting bombarded with change. And that is why we have this structure to keep us sane while locking ourselves down to a known good version. We know it works. I know this will also work. I have no problem using this. By the way, 12, 15, 16, that one will work just fine. I have no problem in running it. But I don't want to get bombarded with change every single hour of the day. I would like to gladly take that change if there is value in it for my customer. That's how I look at it. So don't change for the sake of changing. And I know it is very hard even for me to say this and actually practice, because I am guilty of getting the latest and greatest every single time it comes out. And the trouble it causes. It is, people blame it on Windows and, I don't want to touch the latest version of Windows. I'll go Windows XP and Windows 2000 and all that. Blame people do that. But I'm guilty of taking the latest and greatest. And sometimes things go wrong. I'm not blaming on Windows. Every single software, something changes. Something is likely to break. And in fact, I am not taking the update that you have for this El Capitan. There is the new version of OS that has come out called Sierra. I have not taken it because I will take it. I want to take it so badly, but I'm still not doing it because the class is progressing. You guys will be impacted if I destroy my machine. And that is why I'm holding on to the older version. Once the class is finished, I will gladly take and I will experiment. But until that, I'm restraining myself. And that is something that you should remember, that you're dealing with any software of any nature. Just don't rush into the latest and greatest. Just be careful of a project that you're working. And that's why this structured discipline method of putting down specific version numbers and log them down across the board to the greatest level of depth that you can will minimize trouble for your customer. That's the one thing I would like you to really, really remember. Discipline is important. It helps. And yes, I know I am guilty. I make that mistake. And we are people, we will make mistakes. But at least you have a frame of reference of thinking like this. It will reduce mistakes. Eventually cut down to 0 if you don't change anything. But then people will change. And so will gem files. You will eventually change this number to something like 12, 15, 16, by the way. And you will go exactly like this, 12, 15, and 16, which happened like 5 hours ago, and you will run it and it will fail. Because even though this chef source code is ready, and 15, 16, 12, 15, 16 is there, the Ruby gem may not be ready. So try go Ruby gems, go look for the chef gem and see if we have that. So the latest gem we have is 12, 14, 89. It is not 12, 15, 16 yet. But somebody or some machine or some automation will actually create a gem and put that right here. And at that time, the latest version will become 12, 15, 16. If you run it like this, it is not going to work, even though source code is available. Having the source alone doesn't help. You need to have the appropriate package also ready. So somebody has to build this. You can build and send. They may not accept it, but you can use it. You can use your own build. That's okay. Now, why did I say that? Why did I say all this thing about versions and disciplines and version numbers? Is primarily because you are likely to run into problems in the exercise we are going to follow along in this MySQL server. You're very likely to run into that problem where a latest MySQL cookbook version may not actually work out the way you want. So you go to supermarket and then try to look for the appropriate MySQL cookbook. You will find it has a version of 804. And that is what we have available. And it is created by people at Chef. And what I'm suggesting that we use is older version 563. Simply because I haven't had the opportunity to test out this version. So we are still on an older version. I should actually test the newer versions and try it out. 563 is the last time I think I checked correctly. So I'm still stuck on that one. And they have modified version numbers so many times that I could not keep track with the latest and greatest. But the older version still works, so nothing wrong with it. So don't think that it is going to be bad for you. It's just that this is the one that I know works. That's the reason, the primary reason why we have this version of 563 of MySQL Cookbook is because I haven't yet tried the newer version. As simple as that. Maybe I will find time and try it, and I'll update that exercise at that time. Having said, we need to create a separate folder, not this, for this exercise. So it's going to be slightly different. You can actually accomplish in the same folder as long as you are you're making sure that you're clearly be disciplined around what components are you going to use in this particular folder for your cookbook selection. What does that mean? It means that you open up Atom Editor and you go to the works file in here and you remove the lock. You also remove the gem file lock. And you will remove all the unnecessary things that we have accumulated, like the cookbooks folder can go. We don't need all these cookbooks anymore. The data bags can go. The environment file we have, this one can go. We're just cleaning up, basically. Cleaning up to make room for this new exercise we want to be able to do. So I'm just deleting it the way it was to begin with. And the Burks file needs to change to MySQL with 563. Now I have a new Burks file there. The gem file we need to update a little bit. And actually, no, the gem file will work just fine. It'll work exactly like it is. So there's no need to change that. But since we have deleted the lock file corresponding to the gem file, we need to bundle update again. And so that lock gets created, the gem file lock. We'll also get Burks update to grab the cookbook. This could not find a gem 12, 15, 16 because it doesn't exist. I forgot to modify that. So let's go, what was the number before? The number before we can find out by listing out the gems version, gem list. The version was 12.10.24. So we'll copy that, 12.10.24, and paste it. Now our bundle will work because there is no such gem yet that addresses that need. So we are updating our bundle, nice. And we'll also update our cookbooks by grabbing the cookbook that we want, which is the MySQL cookbook. So this dev.json is also not needed. So let's get rid of that. So our folders are completely empty, almost empty. We can leave this one out. So that goes. Knife RB is not used much yet. All these are empty folders, empty, empty, empty. Git ignore is the way it was. So close. Burks file contains this MySQL cookbook reference, and gem file contains the correct number. And we updated our lock file. We also updating our Burks shelf by grabbing the MySQL cookbook. By running Burks update, bundle exec Burks update will bring down the MySQL cookbook. And it could not create a lock, could not find a lock file. So instead of update, we should say install. So it will actually create that lock file which was missing. And here you see that it installs the MySQL 563 version of cookbook, which, by the way, let's see the version date. So if you go to the source code of this MySQL cookbook, you will find that this is the MySQL cookbook. And the release for 563, what was that? 563 was released on April 2015. That was, it is not that old, although it might look like, 563 versus 804. It's a millennium in between, but it is not. It's only last year, a little bit more than a 1 year time. So it is old, but it's a working functional scenario that we have here. We have updated our Burks file. We obtained that cookbook from supermarket. It required 2 extra cookbooks. This one, Yum, and also Yum MySQL community. Those 2 cookbooks are required as dependencies. So we got them, and the Burks file lock is now ready, like this file shows. And so we now have this cookbook ready for us. So what we now need to do is construct a different node definition. This is going to be node 2, web 2. It will go and belong in the nodes folder, which I have accidentally managed to delete, which means I need to create a new folder called nodes. And in there, I will create a new file called web2 in the nodes folder, web2. .json. And in that file here, I will put this writer, which is basically a way for me to specify override attributes. And I'm not using encrypted data bag right away right now. We will get to that point as to how do you actually use an encrypted data bag in another exercise. Our goal that we have in the desired outcome is to simply get a box running in the cloud with MySQL Server, selected root password that I have chosen, which is 123. So that's what I would like to get. I'm creating a droplet right now. And in that droplet, I am saying that I need to get an Ubuntu box running $5 droplet, cheapo droplet in the San Francisco location with my key, and it will be called my DB box. DB box, or rather I should call it Web2, like the name I've chosen, web2.cloudgenie.us. And that's the name I have chosen for this machine. So Ubuntu, $5, San Francisco, my key pair and droplet and the name, and create. The box gets created. In the meanwhile, I'll go to my DNS server, log in, and then go to the DNS section, look for Web2 reference. And I don't have a Web2 reference apparently. So I'll create one right now, Web2, and put the IP address right here in this location as soon as I get it from the company. So it is going to give me the IP address in just a second. And here we have it. We're going to paste it in that location and then add that record. Web2, add record. So I just created that record. Now it points to that IP address, which is what we have from DigitalOcean, that one. So that establishes a DNS entry for us. And now we should be able to make this node definition apply on that box right there. Now, what does this do for us? So what this is doing essentially is it will run this run list. What does this run list do? It runs a recipe called server, not the default recipe, but the server recipe in MySQL Cookbook. In fact, if you go look at the MySQL Cookbook again on GitHub, you will find that on GitHub in MySQL, not this. You have to go to Cookbook. This is the product. You have to go to get the MySQL Cookbook in Supermarket. And in the Supermarket, we have to go and look for MySQL Cookbook and then go to the source code for the cookbook itself, not the product. So view source for the cookbook. And here you scroll down to the tag called 563. This one. And here you will find that there are recipes and there are two useful. One of them is deprecated. So this is not useful anymore. There are two recipes here, client RB and server RB. There is no default recipe in this cookbook. That's why we are calling it out specifically. I want to make this a MySQL server. I don't want to install the MySQL client software. I want the server recipe to run. The server recipe. That's what I want to run. So I'm going to call it by name. So run the server recipe in the MySQL Cookbook. And while doing that, by the way, use these attributes as overriding the root password, the replication password, and the Debian password. These three values, please override them. So that's what I would like to run and make sure that this server, when it gets set up, is using these values as the passwords. So I'm providing these as overriding attributes. If you don't override, you will receive a password that is called I like random password. That's the password you will see because that's the default value defined in the code. The default value is initial root password is I like random passwords. That's the developer chose to put that as the default, which is I like random passwords, which is not random enough for me, so I chose 1, 2, 3. And I'm overriding that I like random passwords password with 1, 2, 3. That's what I'm really accomplishing in this override section. And then I will save. Let me save this file and close it out. So once I have closed it, what I need to do is make sure that I bootstrap. So in one shot, I will do a prepare command and a cook command all together, one shot. And that is this command. What does that do? Let's see. It's a long command, so I'll make it simpler and actually make the screen bigger. Bundle exec, knife solo, and then the word bootstrap, which is a combination for prepare followed by cook. Prepare, cook, together, both together, one after the other. This IP address is needed if you're not using DNS. If you are using DNS, like I just did, I can go cut all this and run it a whole lot simpler. Root at web number 2, cloudgenie.us. And now I have this structure created. I'm going to copy this and then bring it here and attempt to run it. But before I run, I want to make sure that I can actually connect successfully, because the machine must be ready by now. So I want to test that connection, SSH root at web2.cloudgenie.us, and let us see, does it allow us to connect? Looks like it did. Okay, great, come out of it. We're not messing around with the machines directly. I'm just testing it, whether it works. Testing may not be necessary, but I just do it for the sake of showing it to you that it is working, so we can validate if something goes wrong. And now, bootstrap. Basically, go this. Knife, solo, bootstrap that box, meaning install chef, run chef, be happy. And at the end of the day, we should have a server box running MySQL server database with the passwords that we have chosen. Not what I like random password, but the password that we have chosen to be 1, 2, 3. So off we go. And this is going to install chef first. And then it will upload the kitchen and then run chef. Get the MySQL server loaded. Configure the root password like we have said. And then tell us that everything went well. That's my expectation. That's what I think it will happen, but we'll see. And so it is doing exactly what we're telling it to do. Go grab this version of Chef server. So it is getting that stable version. And then unpacking it to install. Once the installation finishes, it will upload the kitchen. Kitchen upload happens, then the chef will run. So now it is uploading the kitchen. So Burke Shelf will render the cookbooks, the MySQL cookbook, the Yum and the Yum MySQL community cookbook. All these three are getting uploaded. It generates a solo configuration. So sudo chef solo, blah, 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 solo RB, DNA JSON, and something failed. So something failed because of what? No method undefined for nil class. Okay. Let's read. So failures happen, but error executing create. Did I miss a step or something? But I think I will identify what may be causing it, and I'll come back to you on Slack chat as to what happened. But debugging with 6 people looking at it doesn't make sense, so I will debug it later.
Yeah, I followed the same steps here and I ran into the same issue.
Okay, so something must have changed, but we'll figure it out. So we'll figure it out as to what may be happening, and we'll resolve it. It's something must have crept in that I must be missing, or instructions are wrong, or something else is happening, but we'll find out as to what is going on. So we'll get to that point. It should actually succeed because I have run it so many times. and it's an old exercise. So it should work, but we'll figure it out. The bottom line is at the end of this run, we should have a machine that interacts with us. We should be able to connect to that box and basically use our password like we did. Like here, I'm illustrating how you connect to that box using MySQL command, interfacing with it with the password 123, and it connects. That's the outcome verification that we want it to be working. We will have it working after maybe a couple of hours. I should be able to fix it. So once I fix, I'll provide that solution, whatever I did in here in our Slack chat. So you will have that coming back to you once I'm done with it. I'll debug that and understand what's going on. Cool. So does this discussion, was it useful? Was it too intense, too creepy, too nerdy, too bad, too good, whatever that? Let me know. I can adjust accordingly. So please tell me.
Pretty deep, but good.
Yeah.
Okay, good. If it is bad, please tell me. If it is actually bad, don't go that deep. So I will adjust the discussion accordingly. Maybe
No, it was pretty interesting, this session.
Oh, deep is very good.
deep is good. Oh, good to know. Good to know. I just don't want to bore you with stuff. That's my primary concern, is to not bore you. My secondary concern is to make sure that it is actually interesting to you. If I bore you, I will fail in what I'm doing, and I don't want to do that. I don't want to fail. And so that's my primary concern, is to not bore people, because I have seen so many professors in my life that actually bore people, and I have been inflicted with that pain. And I don't want to become a professor, which I am not. So thank you. Thank you. If you want this to be this depth and even further deeper, we will go there. If you're finding it not so interesting, let me know. And yes, I will handle it. No problem with that. And both aspects, going deeper, going shallower, either way.
Yeah, it covers a lot of ground and it's really good.
Thank you. Good to hear. Good to hear. We'll have a lot more ground here, by the way. And so you will enjoy. In that case, I should say you will enjoy. And by the way, most people that actually take the program seem to like nerdiness somehow. I don't know why I attract those people, but they seem to like it, which is nice. I think some nerdiness is useful as long as it has some relevance back to the customer as to what we are doing, why we are doing things, as long as that part is clear. So make sure that I am actually explaining to you how it is used in real life. And I don't want to miss that piece also. So I will make sure that I actually address those aspects. How does it apply in real life scenarios? How do you put that to use? And make me do that. If I'm not doing it, please make me do that. Thank you. Now I will go debug. If you're interested in debugging with me, you can stand online with me. I will do that right away. And yeah. I will stop recording. And you can hang on with me, watch me do it. If you like, you can hang up and go do whatever you like if you don't care to see me debug.
Thanks, Nilesh.
You're welcome, sir.
Thank you.
Thank you, sir.
Bye-bye.
Bye.
And I will now stop recording.